First derivative test. Calculating max and min algebraically. We have discovered how to graphically interpret maxima and minima. Now we will extend our understanding by calculating them algebraically. A maximum or minimum occurs when the slope of the function changes from positive to negative or negative to positive at a critical value. Another way of thinking is that the original function changes from increasing to decreasing or decreasing to increasing. Algebraically, we can find critical values and test points on either side of them to determine the change in slope if there is one. This is known as the first derivative test. Helpful steps. Number 1, find the derivative of the given function. 2, find x values where the derivative equals 0 or is undefined. These are the critical values, or the locations of possible maxima and minima. Number 3, test x values on either side of the critical values, substitute into the derivative, and observe sign change to determine if it is a maximum or a minimum. Number 4, substitute x values into the original function to get corresponding y values for the maximums and minimums. First, let's practice finding critical values. Remember, a critical value is the potential location for a maximum or a minimum. Find the location of any critical values of this function. So first, take the derivative of the function. So we have our function here, we have f prime of x here. Here's our derivative. Identify any values of x where the derivative is undefined. In this case, there are none. Then set the derivative equal to 0 to find critical values due to the slope being 0. So we set this equal to 0, and we solve to find the critical values. So when x equals negative 2, this equals 0, and when x equals 4 over 3, this equals 0. Now we can determine if in fact a max or min occurs at those critical values. So we have our function, our first derivative of the function, and we have found our critical values, negative 2 and 4/3. A useful tool is to create a sign chart to map the behavior of the derivative around the critical values. The two critical values divide the number line into 3 regions. All the numbers to the left of negative 2, the numbers between negative 2 and 4/3, and all of the numbers to the right of 4/3. Now, pick 3 values, one within each interval, and determine whether the derivative is positive or negative at each. For example, the first value that we will pick is negative 3 because that's over here to the left of negative 2, and then we just plug it into the derivative, f prime of x, and we solve and we get a positive number. So this is positive. The numbers to the left of negative 2 are positive. Then we pick x equals 0 because that's right in the middle here in the blue portion. We plug that into the derivative and we get a negative number. So the values are negative between negative 2 and 4/3. Finally, we pick x equals 2 because that's over here in the right portion. We plug that into the derivative and we get a positive result. Therefore, this is positive. So we can see that the slope is positive, and then at negative 2 it switches to being negative, and then at 4/3 it switches to being positive again. So it looks something like this. So you can see we have maximum at x equals negative 2 here because f prime of x changes from positive to negative. And we have a minimum at x equals 4/3 here because f prime of x changes from negative to positive. Now, in order to get our y values of our critical values, we just take our original function and we plug in our x values of the critical values and we get our corresponding y values. So there's a maximum at negative 217 and a minimum at 4/3, negative 41 over 27. For the function, identify the intervals of increasing and decreasing. So we have our function here. So first we take the derivative of the function, and that gives us this. Then this is defined for all values of x. So there's not going to be any undefined slopes here. So then we move on and set it equal to 0 and figure out which x values give us slopes of 0. So by factoring and solving for 0, we get that our critical values are 3 and x equals 1. So we set up our map here, and we have 1 and 3. And so we have 3 portions, less than 1, between 1 and 3, and x is greater than 3. Determine whether the derivative in between the critical values is positive or negative. All right, so we need a value that's less than 1, so we choose x equals 0. When we plug that into the derivative, we get a positive value of 9, so we get positive here. In between 1 and 3, well, we'll choose 2. When you plug 2 into the derivative, we get negative 3, so it's negative. And finally, we'll choose x equals 4 because that's over here in the right side. When you plug 4 into the derivative, we get positive 9, so we have a positive value. So once again, this looks positive slope, and then at 1, it switches to negative, and then at 3, it switches back to positive. This is not the exact graph of the function, but this is just a representation of how the slope switches from positive to positive again. So we can see that the function's increasing in value from x is less than 1, which is here, and x is greater than 3, which is here. And it's decreasing from 1 to 3 in this portion here.